Okay, we'll start. Good morning, everyone. My name is Vishnu Pendyala. I'm one of the directors of ICON. ICON is an employee resource group, ERG, that connects the Cisco Indian community to facilitate professional development and networking for our employees. So a couple of our goals are also to promote the Cisco brand and also business growth. So a few housekeeping announcements first. So that we don't get interrupted by the sounds of cars zooming or honks blowing, I muted everyone because I know this is commute time for a few of us in US. So if you have any questions, please post them in the chat window, and I will coordinate the questions and try to get them answered. The talk is being recorded, so it will be posted on YouTube for future reference. I'll also circulate the URL internally, the recording URL. And so today's talk is on blockchain. According to Julian Assange, the founder of WikiLeaks, blockchain is the most interesting intellectual development on the internet in the last 5 years. And John McAfee says it will be everywhere and the world will have to readjust. World governments will have to readjust. So that is the impact of this technology. To introduce this technology, which has the potential to touch many, if not every aspect of our lives in the near future, we have Varun Vijay. Varun Vijay has a BTech in computer science and an MBA from IIM Lucknow with major in finance and business intelligence. He is working as a technical lead in the service provider accounts with Cisco systems. Varun is a technology enthusiast and ardently pursues his passion. And his passion is how technology is enabling and driving businesses to achieve faster results. How through technology one can unlock growth and drive innovation not only in business but also in human civilization in general. So without much ado, I now give the ball to Varun to proceed with the talk. Varun, over to you.
Okay. Thanks, Vishnu, for the lovely introduction. That's great. So good morning, good afternoon, and very good evening to our amazing audience. So thanks for giving out time to attend this speaker series on blockchain, and that too on a busy Tuesday. So as Vishnu has given a small insight, which is a great one. So actually, blockchain has now become the latest buzzword in the digital space. Ever since the cryptocurrencies such as Bitcoin shot through the roof of their terms of their valuation, there has been a big interest in the technology. Blockchain technology has recently seen an increased adoption and push from major technology companies. Apart from the private sectors, the governments are also mulling over the implementation of the technology. In fact, our Indian Prime Minister, Shri Narendra Modi, have recognized it and said in one of its tweets, technology like blockchain and IoT will have profound impact in a way we live, work, and they will require a rapid adoption in our workplaces. Blockchain, no matter how futuristic it may sound, it is already gaining traction in India. So for instance, few players like banking, financial services, and insurance, which we commonly known as BFSI, and IT industries, have already started to work in this direction. I'll give you an example. State Bank of India, leading banker in our India, is expected to implement the blockchain technology by end of this fiscal year, 2019. So State Bank of India will be going for a full-fledged deployment of blockchain in its reconciliation, remittance, and the trade finance operation in FY19. So blockchain will profoundly change how the world will work. It's said that blockchain will do for business and its value what internet has did for information and communication. It is a foundation technology that will increase trust, efficiency in the exchange of almost anything and everything, ranging from vehicle registration to the tracking medical records, and not just cryptocurrencies. Blockchain, more simply defined as shared, immutable ledger a shared ledger, a shared database has the potential to be the technology that redefines those processes and many others. So blockchain is not about cryptocurrencies like Bitcoin, but it's about the underlying digital foundation that supports applications such as Bitcoin. So reach of the blockchain extends far beyond cryptocurrencies. Today, in this presentation, I will try to cover fundamentals of blockchain and how this technology will revolutionize the transactions and the business networks. So audience will also discover what makes blockchain an ideal solution for streamlining business networks and how they can get immense value from the blockchain technology. So I try to keep agenda so it covers almost everything on when it comes to fundamentals. So it will cover overview on the business networks, current transaction systems and its shortcomings, what are the fundamentals, the key characteristics of the blockchain, how it works, key business benefits, touching upon the Bitcoin as it is the first live case of blockchain, what are the innovation and adoption steps in blockchain, brief about Hyperledger, the Linux Foundation project, what is an engagement of Cisco and blockchain, and questions. So, in this module, we will discuss about business networks. So to unfold this blockchain technology, it's very important for our audience to get an overview on the business networks and the key terms used in it. So we will be referring in these terms here and there. So as business is complex ecosystem, and so it can't be done in isolation. Thus, one needs to benefit from its connected participants like your connected consumers, your suppliers, banks, auditors, attorney, and even your partners. So in business network, wealth is generated through flow of goods and services across this business network. And to enable the flow of goods and services, market plays a vital and important role. So it may be an open market such as auction, a food store or something, or a private market such as a bond market. Okay, going further, I want to discuss key terms which are very important for reference point. So first key term is the ledger, which is a system of record for the business. It records whatever happens in the business. In a blockchain, ledgers are the key. Ledgers are also sometimes referred as database for the easy reference. Second is an asset, which is anything that is capable of being owned or being controlled so to produce value. So there are primarily two types of asset. Tangible, like your house, your cars, which can be touched and perceived, or intangible, which is like your intellectual properties, like your patents and your digital assets. So the third key terms is transaction, which simply an asset transfer from onto and off to the ledger. For example, Bob purchases a car from Platinum Car Private Limited. Transaction would happen, and their transaction would happen if there would be a ledger entry in both of the party. Purchase entry in Bob ledger, which shows that Bob have bought a car, and sell entry in the Platinum Car ledger showing they have sold one car. So fourth key term is contract. These are the conditions under which contract must occur. For example, Bob plays Platinum cars, for example, $60,000, so to buy a car. Then car passes its ownership from Platinum Cars to Bob. So extending it further, like a warranty contract, if car broke down during first year, Bob will either get free replacement or free repair from the Platinum Cars or the car brand. So by these asset transfer, value is created inside the business network. These contracts, transactions, and the records in the ledgers are the defining structure in our economic, legal, and political systems. Thus, it's important to know these terms as we go to the journey of blockchain. Here in this module, I will discuss about the current transaction system and its shortcomings, followed by the latest trends and the challenges. In present world, to facilitate exchange value between buyer and seller, we have several instruments of trust such as currency, letter of credit, online banking, so to name few. There are several innovations in sector, for example, from telephone lines to credit card, from internet power online banking to your mobile banking, which have resulted in improved convenience, speed, and the efficiency in the transaction, which virtually eliminates distance between buyer and sellers. However, as business network is expanding and scaling up in efficiency, cost, and the vulnerabilities are increasing day by day. So following are the limitations which I really want to highlight. Market frictions which are creating uncertainties and thus impeding exchange of assets. Cash usage is mainly a local transaction and use is in relatively small amounts. Actually, and here settlement time are really longer as we need third-party validation and there are presence of intermediaries which adds to the inefficiencies. There is a lot of duplication of efforts as records have to be maintained at every party involved in business transaction. Central systems such as banks are vulnerable to the fraud, cyber attack, even simple mistake can add to the cost and the complexity of doing business. Even secure messaging like SWIFT, which is normally used, have some major shortcomings, as we saw in case of a recently Punjab National Bank fraud, where when suspect Nirav Modi was able to take several rounds of loans on the basis of letter of guarantee and their banks did the SWIFT. So there is a lot of fraud which is possible here. So we still see considerable amount of paperwork and the time-consuming vetting process, which makes the onboarding process a really costly affair. The major thing is financial inclusion is still a big challenge. Access to bank is still limited to almost half of the population which doesn't have it. So in one of the survey, only 24% of sub-Saharan population have access to bank. So thus with this shortcomings, current transactions system requires to go for a radical change so to take care of ever-expanding world of transaction. We now see transactions are growing exponentially, which will surely magnify complexities, vulnerabilities, inefficiencies, and cost of current transaction system. As we discussed in the last slide, with the introduction of autonomous systems in IoT, these transactions will explode. Thus, so to address this, we need an underlying technology that enables fast execution and that provide a mechanism that establish trust, doesn't require any specialized equipment, has no kind of a fees on onboarding cost, and also provide a collective bookkeeping solution for ensuring transparencies and reducing operation inefficiencies. Thus, as we discussed, it has to go for radical change, so to take care of ever-expanding world of transaction. Okay, so in last section, we've gone through latest trends and challenges. And with this need of an hour is to have an underlying technology which is capable of taking care of exponential increase in the transaction. I believe blockchain is that technology. Blockchain is mostly defined as a shared immutable ledger or a database that facilitates the process of recording transactions and tracking assets in the business network. With the blockchain, we can imagine a world in which contracts are embedded in a digital code and stored in a transparent and shared database. It is supported by peer-to-peer network, either public or a private one. And here, every participant in business network uses consistent mechanism with a unique and a permanent audit trail. In blockchain, there is no single point of failure and no way for modification of records. Thus, they are protected from deletion tampering, revision, and thus making it unforgeable. In this world of agreement, every process, every task, even every payment would have a digital record, and the signature would be identified, validated, stored, and shared. So, and just to, and this is the technology behind the cryptocurrencies like Bitcoin and Ethereum. With this, I feel when technology is fully adopted, intermediaries like lawyers, brokers, bankers, whatnot, might not require in going future. So, as an individual, organization, machines, and algorithm would freely transact and interact with one another with little friction and uncertainties. So this is the immense potential of blockchain I'm talking about. If there is to be a blockchain revolution, I think there is one key requirement which we have to accept, like many barriers such as technical governance, organization, and even societal will have to fall. So blockchain is a fundamental technology where it has the potential to create a new foundation for our economic and social system. In this slide, audience will able to establish the parallel between two foundational technologies, that is between TCP/IP and blockchain. So many of us are familiar. It's like in 1972, distributed computer network technology, TCP/IP, has foundation from ARPA and its defense, US defense. Its adoption laid a groundwork for the development of internet. From 1980 to 1990, it gained further traction, and it took around 30 years for fully adopt to this technology. And now, half of the world's most valuable public companies, you name, and most valuable internet, have internet-driven platform-based models. So, the reason to establish this parallel is like we are already aware that TCP/IP initially have a slower adoption, but when massively adopted, major public companies reap the benefits by having business model based on it. So, parallel between blockchain and TCP/IP are quite clear. So, just example, just as email, which enabled bilateral messaging, blockchain-powered Bitcoin enabled bilateral financial transactions. So the development and the maintenance of blockchain is open, distributed, and shared, just like TCP/IP. TCP/IP unlocked new economic value by dramatically lowering the cost of connection. Similarly, taking a parallel blockchain could dramatically reduce the cost of transaction. It has the potential to become the system of record of all the transaction. Economy will once again go for a radical shift. New blockchain-based sources of influence and control will emerge. And the way we interact, the way we trade, and how the value is created. In this slide, I will discuss how the blockchain is revolutionizing the business network. Blockchain would fully transform the way the transactions are done. So earlier in traditional transaction system, which we can see in the top right. So participants of network, as commonly known as nodes, keep their own ledgers and records, thus making it quite complex and difficult to scale up. As we already discussed, these methods have shortcomings such as being expensive as it involves charges and fees of intermediaries, being inefficient as it adds to delays in executive agreements, and duplication of efforts requires to maintain numerous ledgers. And it's also vulnerable because as we discussed earlier, if central system like bank is compromised either due to fraud, cybercrime, or simple error, just by a mistake, an entire business network will be affected. Now, as we can see in the bottom right, now with the blockchain technology in place, participants are now able to share a ledger which is updated every transaction. So every transaction is updated through peer-to-peer replication. Here, each participant acts either as publishers or as subscribers. Shared ledgers or a database enable synchronization of data. It adds to economical efficiency as duplication is reduced, as we have single source of truth and there is no need for intermediaries. In blockchain, network nodes use validation model called consensus that makes network less vulnerable and every identity is identifiable. So, due to digital signature and cryptography, transactions are secure, authenticated, and verifiable. Thus, blockchain have reduced information friction by having consistent information across the business network and having complete trail of transaction. Reduce interaction friction by removing the barriers between participants in a transaction. Here, peer-to-peer network made it possible for direct exchange of the assets. And it also reduced innovation friction by reducing cost and delays of a regulated process. An organization can adopt to the technology. Thus, blockchain will revolutionize the transaction as all uncertainties, the frictions which act as a barrier, so to take business decision, will be eradicated and removed. In this slide, we will cover key characteristics of blockchain technology. So first is consensus, which is a process of validity. Ensuring transactions so to be valid, all participants or nodes in the business network have to agree on its validity. Blockchain ensures that transactions are validated through being appended to the blockchain, making itself a highly tamper-resistant, unforgeable document. Here, I would like to discuss two algorithms which are used in blockchain for consensus building. First is proof of work, which primarily used in public blockchain. For example, in Bitcoin network, consensus is reached through proof of work. Here, in proof of work, participants are anonymous. The network challenges every machine or node that stores a copy of the ledger. So to solve a complex puzzle, a cryptographic hashing algorithm based on its version of ledger. So machine with identifiable copies team up, which are known as mining pools, like in Iceland, so to solve a puzzle they have been given. The first team which solves the puzzle wins, and all other machines update their ledgers so to match that of the winning team. Here, series of the transaction are valid. So, computer randomly trying to guess, thus they're trying to guess, thus they are on the work. So to prove that transactions on blockchains are valid. So one thing I just want to discuss, proof of work consumes considerable computing power and electricity, making it an expensive way to reach consensus. In fact, the power consumption in Bitcoin network is far greater than power requirement of small countries. Such an expense is unnecessary in some private business network where all participants are known. Second is proof of stake, which is a proof of ownership, and this is very cost-efficient alternative. So proof of stake is a category of consensus algorithm for public blockchain that depends on validator stake in the network. So to validate a transaction, validator must have to hold a certain percentage of the network total value. So proof of stake might provide an increased protection from a malicious attack on the network by reducing incentives for attack and making it very expensive to execute an attack. So giving an example, Ethereum, which is another cryptocurrency, is working on POS-based, like POS is the POS-based algorithm, proof of stake. So it has moved to Casper implementation. So to trying to move from ithash, which is your proof of work, so to reduce the computing power and reducing power consumption. So second feature is provenance. So provenance is where blockchain enables the complete audit trail of asset lifecycle and maintains a record how ownership of an asset is changed over the time. Third characteristic, immutability, where none of the participants can temper or change the transaction once it's been recorded onto the ledger, and once confirmed, it can't be reversed, like setting up to the stone, making it immutable. Fourth characteristic is finality, which comes with above three characteristics. As a single shared ledger provides a single source of truth, which is the one place so to determine the ownership of an asset or the completion of transaction. This single source of truth across the business network effectively assure that disputes are very easy to solve and resolve if they are reported. With all the features of blockchain, trust is built effectively within the business networks. In this part, we will discover how the blockchain works. So to describe, let me take example of a very simple transaction. For example, Bob wants to send 5 bitcoins to Alex. The requested transaction for this will be first broadcasted to P2P network consisting of computers which are known as nodes, as you can see in the second block. So this network of nodes validate the transaction and the user status using a known algorithm such as proof of work. Once verified, the transaction is combined with the other transactions so to create a new block of data with digital signature and the timestamp. The new block, which is nothing but a new confirmed transaction, is then added to a immutable record of historical transaction. That is called a blockchain, making it a permanent and unforgeable. So each block is connected one before and owes its name to the way it stores a transaction in the block that are linked together so to form a chain. Group of transactions are blocked into a reversible immutable chain together, and fingerprint of each block is added to the next block. Here in this Bitcoin blockchain example, you can see unconfirmed transactions like Bob wants to send 3 bitcoins to Alex. This request is still part of unconfirmed transaction, which is first broadcasted to peer-to-peer Bitcoin network consisting of computers known as nodes. So the network of nodes validate the transaction and the user status using the known algorithm, which we discussed earlier, like proof of work. Once verified, transaction is combined with other transactions so to create a new block of data for the ledger. As we can see in block 139, it is now verified with multiple transactions, like Lisa wants to send 8 bitcoins. With each block, it contains a limited transaction and a link to previous blocks. So block 137 before 138. So putting one block after the other in a very time sequence format. So blocks are therefore organized in time-related chain in x-axis that gives the name to the whole system called blockchain. So observe the block IDs. They are encrypted using security, so they provide security.
Hey, Varun, there is a question from one of our participants here.
Yeah.
So Suresh is asking, so one of the key questions for this new technology is security. How secure will this new foundation, and what new security technologies will evolve? Any insights on this?
Yeah. So there are 2 types of provenance. So if you allow me to end the slides, because I would be covering provenance of permission and permissionless crypto mining. So in consensus model, there would be a permission and permissionless provenance model. So provenance will provide that kind of security where not everyone can be a participant. So it will give a blockchain a secure platform? So as we go along with the slides, I think the audience will get their answers, because there were few questions like, there was some pseudo crypto mining which was illicit crypto mining which was happening. Thus, it was making, the transactions insecure, and there was some fraud. So permissioned blockchain is the key for that. So I thought I will cover, I will be covering that, but this is the way we will achieve security through permission blockchain.
Okay, thanks.
To use of privacy services. So Vishnu, what I think, if it's good, if we can hold all the questions till the end, because what I think, I was going through a lot of development in recent past, so I tried to cover a lot of things in the slide. So if there are a few questions at the end, we'll love to take it. But I think let's hold the presentation to complete, and then we will take the questions.
Okay, sounds good, Varun. Yeah.
Is it valid ask?
Yeah, that's fine. So participants can still pose the questions. I will probably ask them towards the end of the talk then.
Yeah.
Yeah.
So as we discussed, there are key requirements and key concepts in the blockchain. So to have blockchain for business network, following are the key requirements. First is a shared ledger, which is an append-only distributed system. It is a distributed system of records or database, which runs across business networks. So it is append-only. So you can only add, you cannot change, add one. So second is privacy services. This is the one which adds. Here in blockchain, each participant have the unique ID. There is a specific role within appropriate visibility. Here, user ID profile is like an attestation about participant identity, which helps lower down the uncertainty, allowing users to create control portable identity. They can selectively reveal different attributes about their personality that will help to facilitate trade and interaction. So with this provenance and privacy services, it will have a conceived view. This provides blockchain an ability to restrict access to transaction details. Which is there, a transaction detail can be stored. So it will have an ability to restrict the access of the transaction. Participants can specify the transaction information they are willing to allow others to view. So it's a conceivable view. So privacy services enable policies to constrain network participation, helping organizations to easily comply with data protection regulation like we have COBC, effective at controlling that consistency of data that get appended to blockchain. So third is trust. In a business, trust is achieved by a consensus, that is agreement and validation, provenance, audit trail of entire assets life cycle, immutability, which is uneditable and unforgeable, along with the finality, ensuring a single system of truth across the business network. So the smart contracts. Smart contracts remove the uncertainty of reneging, which was there since barter system. Uncertainty was, what if I don't get back? Smart contracts help us to write a code, binding it to a contract between an individual, and then guarantee that those contracts will bear out without third-party enforcer. Think it about an escrow, which only releases the fund if the conditions are met. Blockchain stores this agreement, set of rules and conditions, which are known as contract, which are governing the business transaction. These are the encoded and shared around the business networks. Contracts will be verified, signed, and distributed across the business network. Once the conditions are met, the contract will execute automatically, and there is no concept of remaking a smart contract. Once it's there, it will happen. For example, a smart contract which contains encapsulated terms and conditions of a shipment contract, and it will be automatically executed when original and untampered shipment reaches a specific GPS location, thus solving the linking problem. So to smart contract is my area of research. I'm the one who's like I'm working on this area. So it is it is kind of a transformative technology which will provide immense value to the customer. So following are the key business benefits with the immutable shared ledger in a blockchain. There is significant time saving. There is a significant time saving while doing a complex transaction which involves multiple parties. Earlier, the time taken was at least 2 to 4 days. But this with blockchain, the time is slashed from days to minutes. In fact, it has drastically reduced settlement time as no verification from central authority is required. In fact, XRP or Ripple is being, instrumental in reducing the settlement times. So the minutes actually. So blockchain resulted in huge cost savings. It is now required less cost to do both internal as well as external audit as it's shared and it's auditable. So earlier this cost was somewhere like time taken was 20%. The audit takes around 20% of their time. So node participants do the network policing, thus reducing the need of an oversight. Also, duplication is eliminated because of the shared database. Also, peer-to-peer networks enables direct exchange in blockchain, thus eliminating the needs of intermediaries and the third party. With the cryptography, the blockchains are secured against tampering, fraud, and the cybercrime. So, privacy service ensure the control on the visibility of each participant in the blockchain. It determines who can see what on the business network. For example, if Bob transfer an asset to Alex, both Alex and Bob can see entire details of the transaction. However, third party, for example, Lucy, can see that Bob and Alex have transacted but can't see the details of asset transfer. However, if an auditor or a regulator joins the network, privacy services can ensure that they see full details of all transactions onto the network. This is possible because of cryptographic technology and use of digital signature. This shared ledger provides a single source of truth, which is increased audibility, enhances operation efficiency, and thus enhancing trust across the business network. So speeding up the transaction while reducing cost results in customer satisfaction, and this will increase the customer delight. So these key businesses benefits like have a lot of incentives for the early adoption. So, so in this part, we will discuss how Bitcoin was emerged. So Bitcoin, a digital currency, popularly known as a cryptocurrency, which is a secure digital currency, secure digital currency transaction using cryptography. It was launched in January 2009 by a person known by a pseudonym Satoshi Nakamoto. It is created as a reward system for a process known as mining, a record-keeping service by use of computing process power. They are mined by people, unlike printed cash, and now increasingly by some business entity as well, for there are huge mining pools established in Ireland. So Bitcoin is unregulated shadow currencies with an interesting property of anonymity. The Bitcoin application works in anonymous mode, so no one knows who are the transacting participants unless it's a wallet. Wallet is an exception. So it requires compute intensive network so to make itself work and solve random mathematical puzzle, which is cryptographic hashing algorithm. Thus, this is required so to eliminate central authority for monitoring, verification, and validation. It enabled by peer-to-peer computer networks of its users. This user network is akin or similar to the characteristics of P2P application like BitTorrent and Skype. So actually it is a first live use case of blockchain. Thus, it is a very important reference point. So I will be discussing about bit on advantage of Bitcoin. So they are cost effective, they are being efficient, they are being safe if done permissible. So Bitcoin and blockchain are really not the same. So Bitcoin is the first use case of application over the blockchain technology. So blockchain can be considered as an operating system. Blockchain provides means of recording Bitcoin transaction over the shared ledger, which tracks movement of any assets, either tangible, intangible, or digital. So just to give an overview, Bitcoin are now being accepted in many retail transactions. In India itself also. In one of the use case, a driverless cars will refuel themselves by doing a Bitcoin transaction with a gas station. So with the emerging powerful use cases, few persons like John McAfee, as Vishnu has already referred, believes that its price would be reaching 1 million by 2020, and it's crazy. Again, he's the same person who predicted like last year in month of October it will reach 15,000 USD, and it did reach it. So I don't know. Don't quote me here, but I just want to give you a reference. So this is a very important slide. So since we now understand the important characteristics of blockchain and how it adds value to the business network, it is very important to understand blockchain adoption and how organizations should be strategically thinking to build a blockchain-powered business network. So in this section, we would try to understand the steps of adoption in the blockchain development. Here, in this, we will discuss the two-dimension framework which will be described effects of evolution of the foundation technology like a blockchain. First is novelty, meaning a degree to which application is new to the world. With high degree, it requires more efforts to adopt. Second is complexity, meaning the level of ecosystem coordination. So for higher complexity, there will be more number of diverse parties that need to work together. Now if we see single use, which is a first quadrant, it comprises of no novelty and no coordination application that creates better, less costly, and very highly focused products which will provide immediate value to the few people. For example, Bitcoin payments, it is an alternative method, but it provides an immediate value to few of the users. Localization, it is a second quadrant which is comprising of innovations that are relatively high in novelty but requires limited number of users so to create an immediate value. Thus, it's relatively easy to promote their adoption. Much of the initial private blockchain-based development took place in financial services sector, often with small network of firms. The coordination requirements are relatively modest. So, give an example, Nasdaq is working with Chain.com, one of the many blockchain infrastructure providers, so to offer technology for processing and validating financial transactions. Bank of America, JP Morgan, New York Stock Exchange, Fidelity, Standard Chartered are testing blockchain technology as a replacement for paper-based and manual processing in areas such as trade finance, foreign exchange, cross-border settlement, and security settlements. Even Bank of Canada is testing digital currency called Catcoin for interbank transfer. Substitution. It is a third quadrant where innovation comprises of relatively low novelty but high in complexity with diverse users. High coordination is needed because they involve broader and increased public uses. For example, cryptocurrencies. These innovations aim to replace entire ways of doing business. Problem which they will face is high barriers to adoption as faced by cryptocurrencies. So as these cryptocurrencies require adoption from every party that does monetary transaction, which will challenge government and institutions that have already been incumbent and handling this transaction from a very long time. Consumers also have to change their behavior and to understand how to implement these new functional capabilities of cryptocurrencies. So transformation is the last quadrant where innovations are highly novel in nature and if successful, could change very nature of economic, social, and political systems. These applications involve coordination activities of many actors and thus gaining institutional agreement and standard and the processes imbibe. Their adoption will require major social, legal, political change, but when adapted, will provide enormous value. Smart contracts may be the most transformative blockchain application at the current moment. There are few early experiments with, for example, such self-executing contracts in the areas of banking, venture funding, digital rights movement. So I believe we are far away from full adoption of smart contracts because so to be effective, it requires full buy-in from all the institutions. So I will now discuss few steps that will help to adopt blockchain strategy faster based on the above framework. So the first is single user application, like where Bitcoin can be used as a payment mechanism. So we already know the infrastructure and the market for Bitcoin is already well developed. The adoption of virtual currency will force variety of functions, including IT, finance, accounting, even sales and marketing, so to build blockchain capabilities. Another low-risk approach is to build a blockchain internally for database and their application, like managing physical and digital assets, recording internal transactions, and verifying identities. This may be especially very useful for the companies which are struggling to reconcile multiple internal databases. Testing out single application will help organizations to develop their skills as they move above and more advanced as they develop more advanced application. And thanks to the emergence of cloud-based blockchain services from both startups and large platform companies, experimentation is getting easier all time. So second is localized application, which are the next natural step for the companies. We are seeing a lot of investment in private blockchain network right now, and the project involved seems to be poised with real short-term impact. Financial services are now finding the private blockchain network with a limited number of counterparts very, very beneficial, and they are reducing the cost and the inefficiencies. So companies are already using blockchain to track items through complex supply chain. For instance, this is happening in diamond industries, where gems are being traced from mines, that is their origin, to the consumers. The technology from these experiments is now available off the shelf. So the third is substitution, where developing the substitute application requires a bit of careful planning, since existing solution may be difficult to dislodge. One way to focus on replacement that won't require end user so to change their behavior, but so to provide them with an alternative. So to get transaction and traction, substitutes must deliver functionalities very similar to the traditional system and very easy for ecosystem to absorb and adopt. A good example would be blockchain-based gift cards, which can be a very good substitute for the normal gift card. It will benefit retailer as they can offer these cards to the consumers, which will dramatically lower the cost per transaction and enhance their security by using blockchains so to track the flow of currencies within the accounts. And without relying on the external payment processors, so third parties. Fourth is a transformative application, which is still far away, but it makes sense to evaluate their possibilities now and invest in the developing technology that can enable them. Such business models are hard to adopt, but can unlock future growth for the companies. So as we take law from example earlier, so they will have to change. So to make smart contracts viable, they have to need to develop the new expertise, both in software and its programming. Transformative scenarios will take off last, but when they will deliver enormous value to the complete ecosystem. So transformative application will give rise to the new platform level players that will coordinate and govern the new system. But one thing is, with the given time horizon, barriers to adoption, and the sheer complexity involved in getting TCPIP level of acceptance, executives should think carefully about the risk involved in experimenting with the technology. That is the key thing which I really want to highlight. So clearly starting with small is a good way to develop the know-how and then build upon it and think bigger. The level of investment should depend on the context of the company and the industry they are. So financial services companies are already well down, so to the road of the blockchain. And so adoption is easy in financial services, but choosing for manufacturing, it is too early. Just to give a small overview, the blockchain is not for everything. So blockchain doesn't fit all the requirement. So even isolated and small organizations should stay away from blockchain. So because the ROI will not be that fast. If one is looking for replacing the transaction system itself, blockchain will not do it. Blockchain is blockchain. The transaction settlement time will take some minutes or few seconds. It will not be milliseconds. So if you're looking for a millisecond transaction, you should stay away from blockchain. And blockchain is a shared ledger, so it will not replace the DB. You still need a DB. And blockchain, if you think blockchain should be used for the messaging application for peer-to-peer, it is not the right way to implement blockchain. So in this slide, we will discuss about the Linux Foundation project that is called Hyperledger. It is a collaborative effort which has created advanced cross-industry blockchains for the business. It was announced in December 2015, which is an open development community which is focused on building blockchain and its related communities. To scale open source projects, it provides frameworks, tools, and trainings. Primarily, there are 5 frameworks and 4 tools which are there in the Hyperledger. So more details can be found in the Hyperledger website. So Cisco is one of the premium members, and it is the founding member on the same. So Hyperledger projects, as we discussed, has 5 frameworks. So you can go further on the Hyperledger member projects to see what are the members and what are the frameworks. So next slide. So here, Cisco is playing a vital role in blockchain development. Along with founding member of Hyperledger project, we have co-founded Trusted IoT Alliance, which is a consortium of 17 companies, so to help to establish a protocol for a blockchain-based Internet of Things. So the mission is so to set a standard for an open source blockchain protocol in a major industries worldwide, thus securing and improving Internet of Things application. We are also engaged in Enterprise Ethereum Alliance for enterprise-ready capabilities. Enterprise class blockchain technologies has potentials to redefine how transactions will transact the value. So we have recently also joined Blockchain IoT Protocol Initiative, which is a consortium which is dedicated to ensure interoperability among multiple blockchains. And this is simply amazing. Great, thanks to Mr. Anup. So it will deploy blockchain technologies at global scale in a decentralized and a heterogeneous environment. This is simply an amazing stuff, seriously. So blockchain will play a significant role in network management, where it will manage the network appliances, not only built by Cisco, but also by different vendors, and Cisco will help to deploy that infrastructure. So to end, so we have 2 use cases. Now, since we have gone through the fundamental of blockchain, it's good to see these use cases now. Taking the retail as an example to start with, I'm taking diamond industry, which we've already discussed in brief. So here transactions are recorded in blockchain, so to help to authenticated high-end luxury items such as diamond, thus making it possible to identify counterfeits like blood diamonds, their origin, are they genuine, etc. For example, diamond diamond blockchain ledger will keep a high-resolution photo of each diamond at every touch point along its journey. It holds certification of authenticity, real-time records of every payment transaction, product details such as card, clarity, diamond serial number. At end of the buying cycle, there is complete, auditable, and indisputable record of information. So, this is also can extend to pharmaceuticals industry where the authentication will help to assure that products are sustainable, compliant, and genuine, so to protect them from counterfeit one. So, in aircraft, there are a large number of parts ranging to million and even having several hundreds of suppliers. So, in one of the article, even Boeing 77 has around 3 million parts and around 900 suppliers, and it's crazy. Thus, in aviation industry, origination of each component part in such a complex system is really hard to track. The information such as manufacturing details, production date, batch, and even the manufacturing machine programs runs to huge number and a possibility of duplication. So across the supply chain, parts and products are vulnerable throughout the processing of multiple transactions, that is either from design to development or manufacturing to shipping. So to solve this, blockchain helps to trace the part as it ensures complete audit trails of each component through the feature of provenance. The single source of truth, that is shared ledger, is accessible by each vendor in the production process. The aircraft owner, maintainers, and the government regulators can easily see what is being transacted, thus helping to improve the business processing and system utilization. With the blockchain, it's possible to track particular part. If there is some fault, specific recall is possible in place of cross fleet. And also, life cycle of asset is now possible with blockchain in aircraft maintenance. Thus, by unifying transaction, industry achieves far better security, transparencies for every step of maintenance processes. And with this supply chain example, I really want to highlight that blockchain will revolutionize how the transaction will work. If that can take 3 million parts, so the transformative technology will give tremendous opportunity for new companies and customers to build a lot of satisfaction. So with this, I want to end the slides. So now, Vishnu, if there are questions, I would love to take right now, if we have time. So
thanks, Varun. I think the talk has generated quite some interest here. So I do see quite a few questions. So I'll probably start with K7's question first. K7 Mukundan is asking, do we have any open source algorithm available for this blockchain? Can this be effectively used in IoT environment?
Yeah, so they are open. They are open source. Like, okay, if allowed, I can see if you give me. I have this. There's a tools which use. So all is open source. It's a modular running distributed ledgers. So there is a proof of elapsed time. So yes, there are some frameworks used in this blockchain, and specifically in IoT, we have one blockchain called Burrow. So it is like EVM machines, and it will use for smart contracts. So even there are some tools here. So since we have less time, I thought I will keep this as a supplementary slide. So we do have algorithms.
Yeah, in fact, the Bitcoin algorithm itself is open source, right?
Yeah, everything. As I mentioned, TCPIP, like a TCPIP, the parallels are, so everything is open source. And actually, just to give an example, when Bitcoin network was developed, every node initially developed themselves through the help of every miner have developed themselves with open source only. So the reason I give Hyperledger Business Blockchain, because if you go through the projects, you will get more clarity. Since Bitcoin have some limitations, I would suggest all the audience to go through the Hyperledger frameworks, so to get more insights. Because actually the problem is I don't want to use Fabric and IBM Bluemix because of but then there are a lot of platforms. Even the composers will provide that algorithm. So that way. But
okay, I'll combine the next two questions. This is about hacking. So Ankur Desai and Sajin Varghese are asking about hacking. So hacks are generally happening on exchanges that are used to trade cryptocurrencies. So if the blockchain is so secure, how is hacking happening?
Yeah, actually the thing is, this is a lot of these miners do permissionless crypto mining. So they don't have privacy services. If a particular miner adds up, they don't need to prove their identity. So that is a problem. So it with the illicit crypto mining, it adds the blockchain to get unsecured. So what happens when a miner adds into it, gets major stake in it, major stake in the transaction, and make it unfraud. In fact, yesterday there was an article in Forbes which I was going through. So it was discussing about permission blockchain. So I would suggest the audience to get more into that permission blockchain, because I don't cover this in the slides, but with the permission blockchain, privacy services will enable that the nodes which are get added are secured, and their IDs are trackable, which is not possible in Bitcoin network right now, because they are permissionable. In fact, as I discussed, Bitcoin is a shadow anonymous. It works on anonymous network now. With privacy service, no one will be anonymous. So that is one key benefit when we move from permissionless to permission blockchain.
Okay, and the next question is about hardware requirements. So what are the hardware requirements to run Hyperledger Ethereum? Is GPU a must? Do you need a GPU? And this question is from Vivek Srivatsan.
Okay, so in case of hardware, hardware, it is not about hardware, it is about the software. So you need to have API over the hardware. So it is all about the API stuff. So there's no particular hardware which is been said for. Yes, but one thing is, for consensus you need lot of computing power. So if you think in a private blockchain, the hardware is not that lot of key requirement. But if you want to go for mining, yes, you need to solve a random puzzle which requires significant hardware requirement. So I want to break this question into two. Mining, yes, you need a lot of you need I don't know if you have seen Iceland mining, it is huge. So mining requires a big hardware infrastructure, but like in private blockchain, in banks or not, so there will be an API installed over your network devices, which will enable the shared ledger.
Okay. The next question is from Deepak Kumar, and his question is, why is so much of resistance on US financial sectors on using Bitcoin, Ethereum, Litecoin, Ripple, etc.? There are so many benefits we know. Is there some challenge as well which is stopping it to grow?
Yeah, they're taking their bread and butter just to stop it. Anyways, so they are like, as I said, it fundamentally you need to get institutional buy-in. And actually, the Bitcoin network works in like anonymous. So there are like chances of fraud. But we have to move from Bitcoin. So people will create some resistance for Bitcoin. But I don't want to discuss Bitcoin here. I want to discuss smart contracts. All the audience should think beyond the Bitcoin. We should think about the smart contracts. Bitcoin will surely have lot of resistance because it will move the transaction system from bank to some anonymous public blockchain. So yes, people will see the business is moving, and the thing is, it is related. It is it is the origin of the money it is not genuine money. It increases there was like a terrorism activities of terrorists exchange money through bitcoins, and in fact a lot of transaction. I don't want to name, like in North Korea and China there was a lot of bitcoin transaction, and they were like, so government found it very like South Korea once like found it to be very unsecure, and they are scared of this level of bitcoin transaction. So they just want to put some hold on it, because in month of October and November we saw a, I think, Bitcoin stampede, so which was crazy. But I think I just want to make an important point. We should not think block. I'm talking about blockchain. So yes, once transformative smart contracts are in place and private blockchain, which we talked about in localization, they will use, they will find very high adoption. As I state in initial beginning slide, even State Bank of India, an Indian bank, is going for a blockchain-based transaction system. Even our Prime Minister said, so we will see tremendous adoption of an underlying technology blockchain, but not Bitcoin. So Bitcoin and this Litecoin and Ethereum will have some limitation. But I think when XRP will catch up, because the Ripple is very fast, and in fact Ethereum is also working on Casper, which will improve the adoption. In fact, Ethereum is a very good live case for it. Will help to help to enable the smart contracts. So yes, there will be a resistance, but I don't see resistance in smart contracts and the localization product like private blockchain.
Okay, I think we are running out of time, so we'll just take one last question. And this question is from Vivek Srivatsan again. And the question is, what specific projects in Cisco other than IoT are interested in blockchain?
So primarily, if we see there are primarily two. We are working on Ethereum. We are working on enterprise level projects. The major projects that I really interested in the heterogeneous it's between multiple different blockchain environment. So two heterogeneous blockchain will interact. That is a key project which Cisco is working. So IoT, see, we have to think on what is the practical use case of Cisco so to adopt. And since we are a network, we are primarily working on IoT. So we will first increase our footprint over the IoT, and then we will think about other use cases. In fact, I am also working on smart contracts and supply chain. Since it is in the research area and it's still in the incubation state, I don't want to highlight much more on it. But yes, just to give a small idea, Cisco we are also interested in working on supply chain and the smart contracts, to name few.
Okay, so thank you, Varun, and thanks everyone. So some of the participants are interested in getting slides. So if they're interested in getting slides, they can send a mail to Varun using his Cisco email ID, I believe, right, Varun?
Yes, it is there. In fact, we can share the PDF file, Vishnu, if they want. So.
Okay. Okay, I will, in that case, I'll post the PDF file.
In the web,
and then
in the WebEx itself, we can post. It's a Cisco public website. Cisco public.
I I'll probably post it in a more open place. Maybe slide share or something. Slide share is good.
It's up to you.
Yeah,
but I
can post in slides. Yeah. Okay, so a lot of compliments to you, Varun. It was really good, some basic ideas, and thanks for the presentation, thanks for the session. A lot of good comments for you, Varun. So thanks again, and thanks for...
it's all about love of blockchain.
Yeah.
I recently published one article on cryptocurrency. I was like, but I don't want to talk about Bitcoin. Actually, I don't want to. Since we are an organization, we should focus on smart contracts and IoT. I really want to.
Yeah. So hopefully with more people like you, we'll be able to do more things like this, because I am also getting compliments for arranging the presentation. So it was a good ending. Thanks everyone. So I think I will end the meeting here. Thanks again, and do join for our future meetings as well. As you know, we started this speaker series in ICON. This is the second talk in the speaker series. We'll probably, hopefully continue. We have a few speakers lined up, so please do join us for future events as well. Thank you all.
Thank you.